Now we see the structure of our project. From the use case graph, we can see that the main aspect is the communication between the actors. The first actor is Telegram, that allows to send data such as username and the password to the catalog, which is the actor that registers all clients who want to subscribe to our service. In the configuration setting, there are the catalog and the one file called from us, FileX, that saves data of people who are using the service. The catalog is a dictionary that hosts a list. Each element of this list as a new dictionary. The FileX in the configuration setting is structured as a catalog, and it allows to use data for the development of the post-processing analysis. Raspberry allows to obtain data from system sensor for processing them. The combination of the evaluation of data from sensors and from FileX allows the system to decide if sending information or not to people that result in the active state. The communication methods utilized here are REST and MQTT. Now we focus on the scripts. The first script is about the server. This allows to save received data from Telegram into the catalog. The actions we can do into the server are different: registering a new account, accessing into the account, modifying the account, deleting the account, and so the service. For doing the last three actions, the server firstly uses a function to check the validity of data sent from Telegram. If information is correct, the requested action works. On the other hand, some messages appear as a consequence of transmitted data. Regarding the registration action, we only check through an algorithm if the ID name already exists or not. If it doesn't exist, the service subscribes the new client to the service. When this script goes, the FileX is immediately created. If the action is a chase, data necessary from the alarm system are written on it. After server work, the first code starts relating to Telegram bot, which work as a client request. Here we can do the same actions as planned for the server, but there is only one action more than it. It is a help function that explains information about the action we can perform into the service. After code execution, we can test the functions on Telegram. Here, we use Telegram Web for convenience. We can test one registration. Writing on Telegram/registration ID and password, we can see how the service answers with a message. In the same time, the catalog records the information of the client. After this, we can test an access. Writing on Telegram/access ID and password, we can see the message of service and the change of FileX. For data reception, we have two scripts, one on the PC and one on the Raspberry device. The last one allows us to receive data from sensors. If they resulted activated or not, we send information about sensor state through the connection to the message broker. For each Raspberry, only one name ID is associated, and it also the topic for sending data. A script hosted by the Raspberry works as a publisher, while the other one on the PC works as a subscriber. The subscriber submits itself to topic list, which number depends by the number of clients, and also it receives message by the publisher. This script modifies the actor state on FileX, and it uploads the sensor state under the correct topic. The two scripts exchange data between them every 30 seconds. At the end, we have other two scripts that are part of the post-processing analysis, and they allow to send the alarm message. We also have an algorithm for simulating the car control unit. The first script analyzes the data written in the support file of active customers, depending on the status of the sensor and the car status, which can be closed or opened. Decides to send the help message or not. The script will evaluate the following cases. Non-active sensor. Regardless of status of the car is opened or closed, there will be no intervention. Sensor active. As long as the machine is opened, there will be no intervention. As soon as it will go to the closed state, a counter will start. If the sensor is still in the active state after the car has been closed, the system will send a telegram help message to the telephone of the person who has logged in. In the event that sensor for 5 minutes do not return any useful result to capture the presence of child on board, then a special message will be sent in which the end of the service is announced. Once you receive this message, you will have to log in again to start a new service. About the emulation of the car control unit, we have a simple script that asks us how we want the state car between opened and closed. The car state is modified on the file X thanks to the command inserted by us by the keyboard. Returning to Telegram web, we can decide how system sends an help message. Now we want to describe how our app is very sensors. We use two sensors that are a button and a movement sensor. The first one is the most important because if it is in the state activated, the system sends an alarm message, while the second one adds confirmation about the status baby. Now a practical demonstration. Pushing the sensor button while we are moving the hands in front of the movement sensor, the system provides to modify the message of publisher and subscriber.